Hello everyone, I am Shravanti. In this lecture, we are going to discuss about functions and scope in Python programming language. Python functions. Why we have to use functions? Whenever you want to increase the reusability of the code in any programming, we use functions. Function is a block of code which is used to perform a specified task. Let's say you have written code to find the factorial of a number, then after some lines of code you need to factorial of another number, then you have to write the same code again. Means unnecessarily you are increasing the length of a code, right? So in order to overcome that problem, once you have written a code, once you have written few lines of code, that can be used anywhere. That is the main funda in functions. Means it is mainly used to increase the reusability of the code. You can reuse the code once you have written anywhere. That is main motive of functions. The functions are divided into different categories, different types. Those are library functions and user defined functions. Library functions, as you know already, as we are using the functions print. Print is a function which is used to print something at console. And we have written power function, right? And square root, seal, floor, and many functions we are using, input. Those are all predefined functions which are included with core Python libraries. The code for this is written already: array, add, for list items, append, extend. Many functions are there, many built-in functions are there. You are just calling those functions so that you can complete your task. Similar to these library functions, if you want to create your own functions, yes, it is possible. That is user-defined functions. User-defined functions are how to create. How to create a user-defined function. In Python, if you want to create your own functions, first it contains two sections. One is function body and name, we use def keyword to create a function. Definitions, we used to call in Python functions as definitions, and name of the function. In order to write function definition, means what exactly the function has to perform. For that, how to create? It contains different paths. We use def keyword and followed by name of the function. Okay. Then the task what it has to complete will be enclosed in this block. That is function body. Okay. And the function body never it will execute as its own. Even though you have written inside your program, never it will be executed until unless there is a function call. In order to create function, you have to learn two things, that is how to write the definition, how to write or create function, and how to call. Whenever you require how to call, you are calling with printf, name of the function. You are calling add function, right? Extend, simply with a name and for passing some parameters into that, right? Similarly, how to call user defined functions. In order to create your own functions, you have to write def keyword. Def keyword is used to create a function followed by name of the function, whatever you want, and then what exactly it has to perform, you have to enclose in this block. This is how you can create. Then creation of a function, never see this is creation or this is definition. These two lines are definition. Okay. Never it will execute when there is a call. First, when you call a function, then it will be evaluated. Now, always function definition you have to write above the call. First few lines of code should be function definition. Then this is a function call with name of the function, similar to printf. Print is name, add is name, extend is name of the function, right? Insert, let's say insert a list of item at second index X you want to insert, right? So this is how we used to call just name of your function. Then what happens? How it will be evaluated? Now here what happens? Whenever your function call is made, your program execution generally starts from here. First thing, even though these lines of code are above the function call, never it will be evaluated. It checks for the syntactical errors, that's it, but it won't execute. Now what happens? Your execution will start from here. First, your control will this is a function call. Whenever a function call is made, your interpreter will start searching for the function definition within the program. Whenever a perfect match found with the name and parameters, then control immediately jumps to that section. Then it starts executing the definition. It starts executing the body of the function. In the body, you have written printf hello world, print hello world, so that this prints hello world at console. Then any more statements in the function definition, you have to maintain proper space. Same number of spaces. Let's say you have written only one line. If you want to write one more line into this, you have to maintain same space. Then only the two statements will be considered into greet block, greet function. Then your control again goes back from here to here actually. There is no assignment, nothing after here. So then it goes to printf. Then it prints the outside function. Function arguments. As you know already, it has to match. Arguments are inputs given to a function. Whenever you call, the number of arguments must match. Let's say it is expecting one argument, you have to match that arguments. So what happens? This function is to greet someone. So I have written def and name of the function is greet. To whom I want to greet, that name I want, then I'll greet. My function will greet. How it will greet? The task is it prints hello and the name at console. Let's say I have given your program execute. This is a function call. Execution will start from here. Then greet John. It takes John as parameter and your control jumps from here to here. This is first step. Then John will be stored in name. John will be stored in name. Then in the definition, hello name. Then it prints hello John at console. Then after that, this is second task. And after that, your control will come back to here. This is third. No more statements. That's how function will execute. Let's say I have written function to add two numbers. I have let's say definition, because in order to add two numbers I need two numbers, so that my definition contain two numbers I am expecting. Name of the function I have given, because it is user defined, I have given it as add numbers. And finally my intention to add two numbers so that my function will perform this action. Num1 num2 will be added and it will be stored in sum. Then it prints the sum. Okay. Now, this is the definition, what exactly the task it has to perform. But this will be executed when there is a call. So now, function call. Function called by passing 5 comma 4 arguments. Then it takes these two values, and in num1 it will store 5, in num2 it stores 4. Then 5 plus 4 will be done, it stores 9 in sum. Then sum 9 will be printed at console, then your control will come back. Okay, this is how functions will be executed, but these are without returning the value. Okay, but if at all if you want to return any value as a result, you can use return statements. Then what happens? See here, I have created a variable square, but find square of 3. Always you have to remember some name and enclosed in parenthesis, that is a function call. Either it might be a user defined function or a predefined function, library function. So find square is not in the list, so it might be a user defined function. That's why we have written code in the beginning, because interpreter, after this if you have written, Always compiler or interpreter has to know whenever you are using new terms. That's why we enclose the definition above this, above the call. So what happens? It takes 3 as argument and it goes to here. And 3 will be stored in num, and 3 into 3 how much? 9. 9 will be stored in result and it returns a result. To whom it will return? Let's say if this line has not written, then the result of this is 9. If you didn't store this, you can't use further. Or else you can go like this, printf. You can call inside a print, find square of 9, find underscore square 3. Directly you can print, but you are written, then it comes here print 9, 9 will be printed at console. But now you are returning the result. So the result of this function call is 9. That 9 will be stored in the square, then it will be printed. Okay, that is how it will return. And default arguments, see, in any language the number of parameters in a function call and number of parameters in the function definition must match. Okay, but there in Python you will be having a flexibility that, to that few are default arguments also you can take. There is no restriction that the number of arguments must match. Means if you are using normal arguments, it must match. But there is another flexibility also. Have default argument values. Default arguments are used when no explicit values are passed. If you have not given any value, whatever the default value we have given, that will be passed to the function definition. Okay. Now here what happened? See, you are calling a function greet by passing allies and good morning. Then what happens? By taking these two values, your program control will jump to greet section, definition section. Then name. In name, it will store allies, and in message, it will store good morning. It will overwrite. There is a default message, but still you have given good morning, so that good morning will be stored in message. So print message comma name means good morning allies will be printed at console. There is another function call, that is the main motive. Whenever you want to execute same kind of statements again and again, you can go with repeatedly. If you want reduce the reduce the increase of code, for that you can go with functions. Now what happens here? You are passing only one value, but there are two parameters. One another is a default parameter, default argument. Means if you have passed a value, then this will take that value. If you didn't pass any value, the default value will be applied. So in name, it will store Bob. You didn't pass any other value, right? Message. So that it takes hello. It prints hello Bob. Okay. There are another type of arguments also. Those are arbitrary arguments. Any language, uh, the number of parameters must match in the function definition and the function call. It must match. But in Python, you have a flexibility function to take any number of positional arguments. Let's say I don't know how many values. See, when you create an array or list, it depends on the user they will take. I have taken 4 values, right? You are calling a function add all and you are passing 4 values. I may pass 5 values, print, add, or 2 values only. If you are passing 2 values, if you have created 4 here, what happens? Excess, more number of parameters expecting. If you have given 4 and I have passed 5, you have passed more, but in the definition it is expecting 4 only. That kind of problems will raise. In order to overcome that problem, when you don't have that, as you don't know how many number of parameters will be passed in function call, then you can go with arbitrary arguments. So arbitrary arguments, for that we use star and arguments. So what happens? 1, 2, 3, 4 will be stored in number. Number will be a tuple now. Numbers will be tuple. So it stores 1, 2, 3, 4. Return sum of numbers. Sum is a function which is used to find the sum of integers in a tuple. So that 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So it gives the output 10. Return. It returns to this. 10 will be returned to this function. So inside this 10, print 10. So 10 will be printed at console. And another flexibility we have, that is keyword arguments. So always we may not remember the name of the arguments. So you means not name of the arguments, position of the arguments. Let's say the definition is expecting. Let's say you have a function that is power, base and comma power as arguments, and it returns power of 2 comma, let's say base comma power. Okay, and means when you call power function, your intention to get 2 cube. Okay, so then 2 will be stored in base, 3 will be stored in this, then it returns 8. But I don't know which is whether base arguments is first argument or power argument first argument. My intention to get 2 cube, but I have written 3 comma 2. Then you will get 9. So instead of overcome that confusion, you can pass the arguments with a name. With a name also you can pass the arguments. Those arguments are keyword arguments. Allows the function to accept any number of keyword arguments. But that is keyword arguments will be specified with double star. See, name and greeting. Two keyword arguments I have passed. So that with the keys and corresponding values. Then for each key value in words, this will be this is a dictionary type, it will pass. Keyword arguments are always dictionary types. So for key value in word items, name and items John, then it frame it as key and corresponding value. Recursion. A function can call another function that you know already, but in Python you can call a function to itself also. A function can call another function, but there is a process you can call a function to itself. That process is called as recursion. Recursion is the process of calling to itself. Calling a function to itself. Let's say you have a function that is recursion. From the main you are calling recurse. Then your control will come here. It will try to execute this block. But inside that you are calling the same function. Your control will go there. So this call is called as a recursive call. A physical world example would be there are two parallel mirrors facing each other, opposite to each other. An object in between them will be reflected recursively from here to there, there to here. Means it will rotate there itself, right? So that is a recursive function. Even it is possible for the function to itself. We know that function can call other functions. It is even possible for the function to call itself. That is termed as recursive functions. Let's have a small example of recursive function. I have written factorial of a number. Let's say here the base condition is mandatory. Otherwise, see, in this example, if there is no condition, it is similar to loops. Whatever the task you can complete with loops, that all you can complete with recursion also. But only one thing is it goes to infinite loops, whereas recursion is goes to stack overflow problems. Stack is limited space in the memory. Whenever a function call is made, immediately one record will be pushed into stack. One record will be pushed into stacks. So what happens when there are recursive calls continuously, because your control will not come here, continuously records will be pushed into stack. It leads to stack overflow problem. Okay, it may crash your systems. So you have to be careful when it has to come out, when it has to start returning the results. That condition is base condition, we used to say generally. See, in this example, to find factorial of a number we have given it as 3. And now num equal to 3. There is a print statement, but this is a function call. Before executing this, always print will be right to left. Now your control will go to search for factorial and num will be taken, and now here the factorial. Control immediately jumps from here to here, and in x it will store 3. Okay, in x it will store 3. If x equal to 1, what is the value of x? 3. So it won't return. Else, return, what happens? You see here, x equal to 3. One more, I'll write here. You try to understand. Okay. So whenever your function call is made, immediately one record will be pushed into stack. N equal 3, you are calling factorial function by passing 3 as an argument. Then one more record will be pushed into stack. Is x, in this case, n value is 3, right? N is 3. So what happens? Return x into x means, sorry, it is x. Here n, it is x. X into factorial of x minus 1 means 2. Means again you are calling function. In this call x equal to 2. Is x equal to 1? No. 2 equal to 1? No. It goes to else. Again x into means 2 into fact of 1. Again one more function call. In this call x is 1. Is 1 equal to 1? Yes. It returns 1. Now this call value is 1. So this whole is 1. 2 into 1. It is written, right? 2 into 1, 2. The value of this is 2. 3 into 2, 6. That's how it will print 6 at console. Okay? This is how recursion will be evaluated. I'll explain once again. So whenever a function call is made, immediately one record will be pushed into stack. N is 3. You are calling function fact by passing 3 as parameter. So in this function call, x is 3. Is 3 equal to 1? No. No, right? So it goes to else. Return. It won't return. See, there is a intermediate. X into means 3 into fact of 2. See, it is not returning. Fact of 2, I don't know. Again, it is a function call so that your control again goes to here only. Then what happens? X is equals to 2. Again, return 2 into fact of 1. Now x is 1. Is 1 equal to 1? Yes, return 1. Means the result of this is 1. 2 into 1, 2. Return 2. Deniki for this. 2. 3 into 2, 6. Now this is 6. This is 6. So the factorial of 3 is 6 will be printed. Thank you.